Today we are solving LeetCode problem 2657, find the prefix common array of two arrays. But instead of jumping straight to the answer, the goal is to understand how to think in steps, so that when you see a new problem, your brain already knows what direction to move in. Now before we start, a quick Attack on Titan inspired analogy. If you are not into it, you can skip to the next timestamp where we begin the actual problem. Think about scouts collecting reports from two different regions. Each side is sending information independently. At first, everything feels scattered and unrelated. But the moment the same detail appears in both reports, it suddenly becomes confirmed information. And once something is confirmed, they do not go back and recheck everything again from the beginning. They just continue updating their understanding as new reports come in. That idea of carrying forward what is already known is exactly what this problem is built on. Now coming to the actual problem, we are given two arrays A and B. Both are permutations, meaning every number from 1 to n appears exactly once in both arrays. We need to build an array C, where at every index I, we count how many numbers have appeared in both arrays from index 0 to I. Now instead of rushing into code, pause and look at the wording. The words prefix, at or before index I, and for every index are not random. They are telling us that the answer is not a one-time calculation. It is something that keeps getting updated as we move forward. So naturally, instead of recomputing everything from scratch at every step, we should try to remember what we have already seen and just update it. Now there are two ways to think about this. The first is the set-based approach. We keep track of what we have already seen in A and what we have already seen in B. As we move forward, whenever a new value appears in A, we record it. Then we immediately check if this value has already appeared in B. If it has, then this value is now present in both prefixes, so it contributes to the answer. Same logic works when we process B. This approach feels natural because it matches how we think in real life. We are just checking whether the other side has already seen this value before. The second approach is frequency-based thinking. Since this is a permutation, every number appears exactly once in A and exactly once in B. So instead of tracking two separate histories, we can simply count how many times a value has appeared overall. The moment a value appears for the second time, we know it has shown up in both arrays, so it becomes part of the common count. Now let us take one example to make this concrete. A is 1, 3, 2, 4, and B is 3, 1, 2, 4. We start with nothing seen and common equal to 0. At the first position, we see 1 from A and 3 from B. Nothing connects yet, so common stays 0. At the second position, we see 3 from A and 1 from B. Now both of these values complete their cross-presence, so common becomes 2. At the third position, 2 appears in both arrays, completing its match, so common becomes 3. At the last position, 4 appears in both arrays, so common becomes 4. So the final answer becomes 0, 2, 3, 4. Now let us move into the code, and this is where the real understanding actually happens. We create two sets, one for values seen in A and one for values seen in B. Along with that, we maintain a variable called common, which keeps track of how many values are currently shared between both prefixes. We also create a result array because we need to store the answer at every index. Now we start a loop from the first index to the last index. At each step, we receive two new values, one from A and one from B. We first take the value from A and add it to the A set. This is simply us remembering that this value has now appeared in A's prefix. Now the important check comes immediately after that. We check whether this value already exists in the B set. If it does, that means this value has already appeared earlier in B, so now it is present in both prefixes, and we increase common. Then we move to the value from B. We add it to the B set so that future checks can use this information. Then we check if this value already exists in the A set. If yes, it means B has now completed a value that A already had, so we again increase common. After processing both values at this index, we store the current value of common into the result array. This is important because at this moment we have fully processed everything up to index I. Now about time and space complexity. We go through the array only once from start to end. At each step, we are doing simple insert and lookup operations in sets, which on average take constant time. So overall, the work grows directly with the size of the input, which makes it linear. For space, we are storing elements in two sets. In the worst case, every element gets stored, so space also grows linearly with input size. Now, common mistakes and gotchas. One common mistake is trying to go back and recheck everything from the start at every index. That feels logical at first, but it repeats the same work again and again and makes the solution unnecessarily slow. Another important point is that this only works cleanly because the arrays are permutations. If values were repeating inside a single array, then the idea of second time means common would no longer be reliable. A third mistake is forgetting that both arrays contribute at every index. You cannot treat A and B separately or only update one side because both are building the prefix at the same time. Now, if you zoom out, the real idea behind this problem is simple. We are not solving a new problem at every index. We are just updating one evolving state as new values come in. That is what makes this efficient and reusable across many similar problems. And you will see this exact pattern again in problems involving prefix tracking, frequency counting, and running state updates. Now, if this explanation made things clearer and helped you think instead of memorize, then like the video, share it with someone who is struggling with prefix problems, and subscribe for more breakdowns like this. And with that, Tatakai.